It's my pleasure to introduce Dr. Brian Mesmer from the University of Alabama in Huntsville, presenting his research updates for CERT ART-016 on integrated mission equipment architecture process for virtual lift systems. So with that, Dr. Mesmer, I turn it to you.
Thank you. So yes, I'll be talking about our work today on IME's architecture process for vertical lift systems. Of course, I'm just the representative, so I'm the PI right now, and the other individuals that are working on the project. So we have Tom McDermott from Stevens, we have Dr. Paula Colopy from UAH, Dr. Dale Thomas from UAH, and then our awesome 6 undergraduate students below, Jenny, Catherine, Christina, Paul, Andrew, and Olivia. And we're really, well, we're a collective within engineering. So we have mechanical engineers, aerospace engineers, industrial engineers, and systems engineers all working on this project together. So with that, I want to talk a little bit about the goal of the project first. So the goal here that CCDC is looking for is to enable rapid integration of flight-capable technology in a manner that is sustainable over the life cycle of a platform, system, or component. So if that's the goal, then what's the problem? Why can't we do this right now? Well, really, in order to do this, we need a comprehensive architecture to be developed to enable us to be able to communicate throughout the organization certain intent. So from the Comprehensive Architecture Strategy document, we have the quote of, "To a large extent, the military services develop military systems through independent procurements using a unique set of program requirements implemented by a single vendor," which essentially is implying vendor lock there. It often it results in ad hoc architectures that are the result of technical design decisions. So not only do we have architectures that are not consistent throughout the organization, but that are being developed kind of on the fly, but also they're being developed from the bottom up. Since they're the result of technical design decisions, it's very difficult to then develop an architecture from the top down and have the technical design decisions at the very end. A process is also needed to incorporate program business objectives into this architecture and disseminate that through the organization so that when people are making decisions, whether they be design decisions or architectural decisions, they're incorporating all of the stakeholders' preferences, including functional and non-functional or business objectives in their decision making. Again, this issue of business objectives is really important here. And when I'm talking about business objectives, I'm talking about things like interoperability, upgradability, maintainability, a lot of the abilities that are not related directly to the system's performance metrics. When program business objectives are identified as important right now, they typically take the form of a desirement, which is a weaker form than a requirement that is used for the performance metrics right now. Right? They're not created equal, which is an issue. So when businesses and corporations are getting these preferences disseminated to them from above, they're really having to struggle to figure out, well, these are the performance requirements that we are given that we must meet. But then we also have these desirements that, well, they care about upgradability, but they haven't really defined them. They haven't really explained how we're supposed to meet them. And that becomes a major issue, right? And that's one of the issues here. Desirements are often not defined in a common way. It's very hard to say what interoperability means because everybody that you ask in engineering is going to have a different understanding of what that is. And it's going to have a different metric for measuring it. So we must have 20 units of interoperability, right, in a perfect world. Well, we don't even know what the units are to understand what that means. It leads to inconsistency between programs where you have some people really focusing on business objectives and some people not at all, or you have the same business objective pushed through the desirements to these different organizations or different groups. And it's very confusing to figure out what each one of them means, what each one of them is doing, because you can't compare across these programs, even if there's an understanding of the ability within a program. And finally, it's not verified or validated because we don't really know even how to measure it right now, right? The validation is a bigger issue, right, in systems engineering and architecting in general, but these abilities don't even have a measurement to base that off of. Again, examples of both. So we have operational performance concerns, mission capability, performance. Typically, they're not dependent on the budget. They're expressed often by a system, so they're system characteristics, where business and non-functional concerns are more focused on operations sustainment, future costs and schedule, update, upgrade, interoperability. They're highly budget dependent, and they're also time dependent, right? We are decently good at capturing these performance concerns. At least we understand what the performance concerns are in general. But the business and non-functional concerns are the big gap that this project is really focusing on. So non-functional requirements, these business objectives, are only achieved right now in an uncoordinated manner. So some groups will focus on them heavily and some groups will not. Some groups will have some kind of a bar to meet, some groups will not. What happens then through this uncoordinated implementation is that long lead times get generated. There's cumbersome improvement processes, limited hardware reuse, lack of software reuse, and so on. Right? We're missing the ability to understand what these business objectives are in a consistent manner to give us the efficiency and effectiveness improvements that we would hope to get by pushing those through and disseminating them through. Baldwin is quoted as saying, combined with the extensive testing and airworthy qualification requirements, these factors have begun to affect the ability of the military community to deploy new capabilities in a timely manner to the warfighter. You can imagine that if we're trying to push even the business objective of capability out and make that a real important requirement, we don't really have the capability right now through the current architecture strategies, which fights immediately the ability to deploy new capabilities, right? Throw in interoperability, throw in upgradability, right? If we come up with things rapidly and we generate them in our engineering skill set, getting that out to the warfighter is going to be very difficult if we haven't ingrained these important business objectives into the decision-making process. All right, so that's kind of what the goals are and the high-level objectives. Let's talk about a little bit about the project background here. So there has been some work in the field, and this is not a new idea that we're looking at, right? So it's important. Business objectives have been identified as being important to the United States. Government has had an initiative to acquire systems with a MOSA, with modular open architecture, so MOSA, since 1995. And there's also high-level strategic level business concerns that we've been focusing on. Operation and sustainment costs, the time needed to field capabilities, the update and improvement of those capabilities over time. These are all have been expressed, but again, there's not that way to represent them and to communicate them out throughout the organization. Typically, it requires low-level design decisions before a system has been selected in order to enable this modular open architecture, right? You have to pretty much make your decisions at the very bottom, feed that up, this bottom-up approach, in order to generate your architecture. And there's right there is a major issue, since our view of an architecture really should be top-down, communicating and disseminating those preferences throughout. Decision-making in the Army has the idea already of mission command. So there's already this ideological understanding of taking a top-level stakeholder's preference and communicating that throughout the organization, and people then make their decisions based on that top-level preference. So commission command is a stakeholder value preference model used to direct a decision-making process, right? Essentially, we're executing the commander's intent through this mission command structure. It combines a centralized stakeholder's intent with a decision execution at the lowest level of the hierarchy that will resolve an issue. Right? So this ideology already exists. Right? This mission command highlights that the ideology that's needed to implement a CAS approach is present, already existing within the Army. And the main issue is that the methods have not been identified or formed, right? So not only are they not present in other areas, or that we haven't identified them from other areas, but if they are needed, if there's a major gap, we haven't developed them yet in order to implement the ideology and architecting to enable this decision-making throughout the organization that is consistent with this top-level stakeholder. And in that preference communication, we would want to capture these business objectives, right? So not only do we not have the structure to communicate that out in an architecting world, but we also don't have that way to represent the business objectives at the same level as equal to those functional requirements. All right, so this ideology already exists, but now let's look at the project-specific objectives. So what is our mission here? So UAH and Stevens and the CERC as a whole is assisting the IME team in maturing the CAS approach by researching, developing methods for consistently applying CAS across multiple programs. So while there is the future vertical lift that we have kind of focused on, we're trying to step back and make sure this is really applicable across a wide range of programs. What we're specifically doing is employing our expertise in systems engineering theory and practice, and particularly looking at the use of expressed preferences to guide decision-making and mathematically align the contracts and the incentives in those contracts to carry this guidance across to industry. So it's great if within the Army we have this communication of stakeholder preferences, but we also have to realize that the main communication mechanism with industry is through contracts. And if we don't fix those contracts, well, not necessarily fix, but if we don't restructure those contracts to capture this stakeholder preference and to be able to incentivize the companies to make decisions according to the Army's stakeholder, then we're missing we have a big issue there, and we'll go into more detail with our preliminary results as we go through this presentation. So what's the anticipated impacts if we're able to implement these methods into CAS to enable this communication of a stakeholder desire? Well, we expect that we will move away from an ad hoc approach, which is commonly used right now and that is heavily reliant on heroic designers, and move more into scientifically rigorous, repeatable, and reliable methods within the CAS approach. Ideally then, if this were to work, we would be preventing vendor lock. So we'd be able to look at a larger swath of companies and be able to communicate our desires out and really get back the best designs from them, making decisions from them according to the stakeholder that we care about. Hopefully it's going to increase the reuse, upgradability, expandability, and sustainability of developed and acquired systems. So why would that happen? Well, because we're communicating those business objectives out to those decision makers, right? That's top of their mind now. And hopefully then they'll be making decisions to improve those ilities, those important business objectives. Same thing with interoperability within the Army systems and within the Joint Force, and increase the rate of innovation and the number of providers in the industrial base, really going back to that reducing the vendor lock phenomenon. So we're not the first ones to look into this. There has been prior Army work in this area. And right now, the current approach in CAS is to first start off with documenting and managing those business and technical objectives. And the way that we do that is that we establish these key business drivers. We have these high priority quality attributes that form then the key architectural drivers, and we express those through business objective requirements. Right? We gather this information through workshops and surveys and interviews, and we then use some subject matter expert fed data in order to develop what are the key architectural drivers, what are the key business objective requirements, and whatnot. We then establish the elements of performance and capability that will be influenced by the architecture, and we express those through TORs, so technical objective requirements. The non-technical requirements, those business objectives, are managed and contracted with the same rigor on the same equal level playing field as those systems functional and performance requirements. So right now we're ingraining into this approach that these business objectives are at the same level as the functional requirements. There's been numerous different documents created to emphasize this ideology and this method. So the CAS paper is really the ideology paper. It kind of sets the stage for this approach, this architectural approach. And then the ADM is really the methods that you would use in order to implement. And the ADW is a Excel worksheet that implements all of those methods in one, and really focusing on the couplings between the different attributes. Okay, so that's the prior work from the Army. Then what's our research plan here? So our long-term goal then is to provide a validated, rigorous systems architecture process And we're going to base that on evidence and theory from a broad collection of disciplines applied to a system of systems context. So we're not going to stay just within the field of system engineering or just design engineering or architecting. We're really going to broaden this up and look at psychology, look at marketing, look at business, look at all these different fields that may have already identified methods that would be useful in the CAS approach. But we have to be careful. We have to be able to look at those approaches and say, does that make sense for this context? So our more detailed steps would be to verify first the intent of CAS, make sure that we're all on the same page. Analyze CAS as a transformational system in a complex environment. Make recommendations for improving the effectiveness of CAS itself. And then we're going to better integrate CAS with acquisition and engineering environment and improve the transition of CAS into wider usage. Right? So this step-by-step approach in order to get CAS more used out in the real world. We have 2 years for this project. It started last March. So from March until essentially now, we've been doing exploration and problem definition, understanding the intent of CAS, understanding where it needs to go, what are the gaps and what are the weaknesses. From now until essentially a year from now, we're going to be doing methods identification and recommendations, going out there, finding different methods already out in the field, potentially forming some methods if we need to, understanding the context, the assumptions that they were built upon and how they were validated, and then recommending the ones that we feel are appropriate based on the evidence that we've gathered. And then the last few months of the project really looks at disseminating the work and training the user base. So going out there, working with DAU, developing syllabuses, developing workshops, developing wikis, and getting that information out there so that people can be engaged with it and we can be engaged with them and communicate to them different things that we think are important and that they should be focusing on, or simply training those individuals. There's going to be 4 key areas that we're going to be looking on as we've been doing the investigation and that we have been doing in the past 6 or so months. And that's been focused primarily on preferences. So we're going to be looking at eliciting preferences, representing preferences, communicating, and executing preferences. The research is currently looking at capabilities of a broad collection of fields. So I mentioned this before: engineering, psychology, business, marketing, software engineering. We're looking at a wide collection of disciplines in order to figure out what best are the methods to implement into CAS. And the approaches that we are looking at are going to be based on evidence. So we're trying to avoid heuristics. We're trying to avoid ad hoc methods that don't have the backing that we really are looking for. We want to be rigorous here. We want to make sure that we have evidence that we can point to and say, this is why this method or approach should work, and this is why we can implement it into CAS, and not just make these leaps of faith and hope for the best that these different methods will work. So we'll be looking at the different approaches, theoretical and their validation limitations, and be able to understand that when we put it into this new context, what are the limitations? How are they restricted? Are we only able to look at certain systems with these approaches, right? And beyond that, we're not too sure, right? Have big warning signs and say, listen, you know, it's great for these systems, but we're extrapolating at this point, and we're going beyond where we possibly should be constrained within. So going back to those 4 topic areas associated with preferences, so let's walk through those really quickly. So first, we start off with our stakeholders, that person or that group of people that really matter, that really have the say in what these system of systems and architecture should be looking like. We are going to then elicit the statements and desires from those stakeholders. So these are things that they care about, right? Represented through statements and desires. From there, we're going to try to represent those in terms of preferences. And these preferences could be in the form of requirements. They could be in the form of value models. There's a whole slew of different ways to represent these. And we're going to be examining that and understanding the mathematics for taking these statements and desires and transforming them into something usable in documents and contracts that we can then disseminate through communication. So understanding the structure and incentives to build up this communication framework to disseminate these preferences out to the decision makers so that they can then execute at the very bottom their decisions and make good decisions based on, going all the way back up, the stakeholders' preferences. Right? So enabling consistent decision-making throughout the organization based on the stakeholders' preferences from the very top. So that's how we've broken down it. And this isn't simply linear here, right? There can be lots of loops back. So this is seen most often in communication and execution. So in order to communicate, you're going to have to execute some decision-making in order to establish some categories of systems or some architecture in order to enable further communication, and that'll enable further execution. Same thing for elicitation. There's going to be elicitation of stakeholders lower down. So if we are trying to incentivize different companies to make certain decisions, we have to first elicit their statements and desires. Otherwise, we can't form those incentives appropriately. Right? Ideally, we incentivize, we use mechanism design from game theory in order to drive certain behaviors that is preferred by the top level stakeholder. All right, so let's talk a little bit about our exploration and problem definition stage that we've been in. And the first area that we want to look at is the rigor in systems architecting, right? So putting the preference stuff to the side and really understand where is the current state of the art. Right? And what we saw initially, and what I'm sure all of you have seen, is that it's really based on heuristics. There's very little mathematical to support it, at least from our end when we first looked at these, right? So we then asked the questions, where do these heuristics come from that is the basis for systems architecting? And what evidence exists that shows a heuristic is a trustworthy tool? In order to explore these questions, we collected heuristics from a set of different systems architecting texts, and we formed a database. So the four main texts that we looked at was the Art of Systems Architecting by Meyer and Richten, the Augustine's Laws document by Augustine, Systems Architecting by Richten, and Systems Architecture by Crawley, Cameron, and Selva. And the main source in our database that really was where we got a lot of the evidence and where we were able to trace down what are the supporting arguments is the appendix from Meyer and Richten and Augustine's Laws. So we identified the evidence used to support those heuristics, and then we categorized those evidence and coded them. So the way that we coded them is that, well, first identifying the evidence, we trace the citations down to figure out what's the core, right? So unfortunately, a lot of these heuristics will reference a document, and then that document will reference another document, and it takes quite a while to get down to, well, what's the real nugget here? What's the real evidence that all of this heuristic is really based off of? So we had to do that. That resulted in a lot of going through citations, tracing it all down. And then once we got to what we thought was the evidence, what we identified as the evidence, we then codified it using case study, mathematics, history, conversation, or no further evidence. And again, this is preliminary coding. We are going and improving this as we go along. And then we did some additional coding. So we looked at the heuristics itself and asked, is this systems or an architecting heuristic? Is this general or domain specific? Is this part of the architecting process? And what does it relate to? So we asked these questions as well. Our findings so far, and again, this is incomplete and we're modifying the code still, but it gives us a pretty strong finding so far. So if we look here in the figure on the left, we have this dark blue is case study, right? And we have orange as conversation. We have green here, roughly 20-ish% as no evidence, which is alarming for heuristics that are been identifying in seminal work in the community. And then we have mathematics as this small silver area and history as this yellow area and case study and mathematics as this light blue area. So the things that you would regularly build a field upon, strong mathematics, really is a very small sliver here of the evidence that supports different heuristics. Over here, we break down the case studies. So we have one case study or a group of related case study as this dark blue, and we have unrelated case studies as this orange. That's a little bit worrisome, right? We have a lot of things based on no evidence, based on history, based on conversation. That is not, in my opinion, not a strong amount of evidence, or not a strong type of evidence to be building a field upon. We looked at the stages that the different heuristics were focused on, relating back to our 4 areas of preferences that we're examining. And we see that the bulk of it is in communication and implementation, and very little of it is in the top end, is in elicitation and representation. And the fear here is that if we don't understand how to elicit and how to represent preferences at the top level, it's going to be weak data in is going to produce weak data out. Right? And while it's not strictly linear, it has some linear tendencies, sequential tendencies here, where you need that top level stakeholder preference information to elicit properly, to represent it properly, in order to enable communication and implementation in an effective manner. So as kind of a summary of these preliminary findings, is that the basis for much of systems architecting lacks rigor. And a start from scratch approach may be necessary, but we may be able to adopt from other disciplines some key findings that they have, some methods that are grounded in rigor, understanding that the assumptions and context must be understood when we apply it to this new context, right? So if we take a design engineering method, we need to be able to understand that this new context is much larger. We're looking at system of systems. We're looking at entities. And we'll deal with some of that in just a second about how that could be a difficult task in itself. So let's now get into the preference areas and talk about different preliminary research that we are going through. So for first, looking at elicitation. So here the current method is scenarios, document analyses, and workshops. And the problem right now is that it doesn't capture risk preferences. It can be highly subjective depending on who is the expert that is giving the workshop, who is doing the interviews and the questionnaires, and it's not falsifiable. So what are some areas that we plan on researching here? Engineering design, psychology, marketing. These are areas, different areas that we're looking for new approaches that may have some rigor built into it. So what are some of the challenges that we're seeing right now? And this goes back to that design engineering example from before, where right now in architecting, a lot of people say, well, why don't you just use surveys and conjoint analyses, things that we've been using in design engineering for decades, and just apply it to system of systems? Well, there's a challenge there. So we see here at the bottom right an example of this conjoint analysis applied to a typical design engineering example where we're looking at different vehicles. And it's very easy to characterize these vehicles. SUV, truck, car, we know what that means. Engines, a V6, a V8, the liters, we know what that means. That's measurable. We understand that typically a V8 will have more power than a V6. Price, easy peasy, right? We all understand what a dollar is worth. Now put this in a system of systems context in this very high level architecting decision framework. What does that look like? What do different architectures look like? What do different system of systems look like? While we're capturing these things in terms of entities, we don't all agree on what those entities mean. We certainly don't know how to measure those entities, right? So this conjoint analysis, while it works great for when we understand the system very clearly, our system in this context in architecting is really this system of systems and this architecture. And we don't have a grasp on that well enough right now to use these methods. So that's a big challenge right now. So what are we going to do to fix that, right? We're going to identify approaches from psychology, marketing, design engineering, and system engineering. We're going to understand those assumptions and context that they are developed within. And then we're going to select, adapt those approaches into CAS, and then implement and demonstrate. And that's the next year's worth of work. Moving on to representation of preferences. So here right now, we're documenting statements and forum results, and we're using those to generate forcing functions and heuristics in order to write requirement statements, right? And that relies right now on some couplings that haven't been fully validated, and it does not communicate risk and temporal preferences, and it leads to limited exploration of design space. What are the areas that we're going to be looking at in order to make improvements to CAS in this representation of preferences world? We're going to be looking at value-driven design. We're going to be looking at MDO, and we're going to be looking at value-based requirements. The big question here when we look at representing preferences that we have started looking into is what are the processes currently used to form these common representations of preferences, and are value-based requirements applicable to CAS? So we looked at different processes to develop requirements from NASA, from DAU, from CBOC. And while you can't read each word here, very obviously, these are different processes, right? And that's a little concerning, right? So here we would think that even for the functional constraints, we'd have some kind of process that is consistent across different domains and different agencies. But in fact, we don't have a consistent process, right? So the simple act of forming a requirement here in this case, or representing preferences in the general case, is challenged right away. In addition, the way that we commonly represent preferences through requirements has some flaws. So we see here in the bottom left, if we were to take a design space, put requirements in it, anything that meets the feasible, that is within the feasible region, these different stars which represent alternatives that may be chosen, well, they're all just as good. They all meet the requirements. A better way to go about this, while you can still use requirements to eliminate certain infeasible regions, is to apply an objective function or a value function in order to be able to communicate the preferences of the stakeholder within the feasible region, to allow the decision maker to make the design or the alternative here, to choose the best alternative that best meets those stakeholders' preferences, whether this be an architectural decision or whether it be down at the bottom, a terminal component decision. That information is highly useful. We started looking at value-based requirements engineering, and what we're seeing right now is that there's a inconsistency in the VBRE community. It doesn't seem like there's one process in order to follow, right? They tend to contain future integration and update potential that business-oriented requirements formation lacks. So we see that there's usefulness here, but there's some weaknesses that we need to be able to understand as well. And we're in the process of understanding that and seeing, does it actually make sense to bring this into CAS? And we see potential, but we don't see rigorous methods there yet to apply. So again, what are the next steps? Well, this is going to be a common slide. It's going to be over and over again. Here we're identifying approaches from value-driven design, requirements engineering, and MDO. And we're going to characterize the assumptions and context, select the best one, adapt it appropriately for CAS, implement it, and then demonstrate it. Moving on to the third topic of preferences that we're focusing on is communication. And here we're trying to communicate those preferences and understanding what structure and incentives we need to be using in order to enable the best communication. So there's two areas here to explore: internal organization and external organization. Internally, we have requirements flow down, and we have the centralized decision-making process, ideally through a mission command context. And externally, we have contracts that we use to communicate with the contractors. The problems, well, again, we have couplings that were not fully validated yet. There's some inability to communicate risk and temporal preferences, and that can again lead to limited exploration of design space. For the external organizations, we have an issue here of the most plausible liar strategy coming into play, which is a game theory understanding that we could be susceptible to that if we're using the traditional contracts. The areas that we're looking to explore in order to do our research is value-driven design, MDO, value-based requirements, and objective function that's centered around contracts. One of the main questions that we had in this early exploration phase was what game theory tools can be used to improve the communication of preferences within and outside of an organization. We first looked at the contracting process, right? So we have our pre-bid process, we have our evaluation process, and then we have our renegotiation process. And we're looking at different spots within this process in order to apply game theory. And we know that we can do that through anytime we send out information and anytime that we do the selection. So we want to apply here mechanism design, and mechanism design is essentially the idea that given a request for proposal, there may be this plausible liar strategy where the contractor is trying to get their bid selected and then renegotiate afterwards in order to best get to a field that they can actually meet, right? In game theory, there's a lot of research that's done in mechanism design, and mechanism design here is the ability to change the rules of the game in order to drive a decision made by another player, in this case, the contractor, to best meet the needs of another player, or in this case, the overlord of the game, which is the Army. And we're looking at different methods that the Army currently uses in acquisition in order to understand where we can apply mechanism design in order to best meet the stakeholders' desires, looking at lowest price, technically acceptable methods, best value methods, and trade-off processes. Again, the next steps, well, we're going to be identifying approaches from VDD, from requirements engineering, MDO, and value-based requirements, and game theory, of course. And we're going to characterize the assumptions and context of those different methods, select them and adapt them for CAS, and implement and demonstrate. Finally, the execution phase here. Now we're looking at how do we make the decisions knowing that we have the preferences communicated to us from the stakeholder. Right now, the system is decomposed into platforms and variants, and the requirements are used to create a bounded feasible region, and design choices are executed within that region. We have issues of satisfying requirements and there not being insufficient context to explore the design space. We talked about that before. And decisions of where and how to decompose systems are very ad hoc. Again, we mentioned that before in the heuristics that are driving some of these decision-making processes. In order to examine this, we're going to be looking at military decision-making processes, VDD, MDO, and software engineering. So essentially, the software architecture questions that we had was, what is out there? What can we apply to CAS in order to improve it? One of the areas that we first looked at was family of systems architecture from software architecting. And we looked to see, well, how does this look like in CAS? CAS has 3 different levels of their architecture: reference, objective, and systems. So we can take this previous family of systems architecture idea and apply it. We could have our reference architecture, our objective architecture, and our system architecture, and be able to examine the different combinations of them when we're making our architecting decisions. We looked at DevOps. We were looking to see if that's applicable to our CAS approach. We found that, yes, it has some applicability, but it might have some struggles, and we're dealing with that right now in our research. We also looked at patterns and tactics. Patterns here dictate general architectural decisions and not the implementation of the architecture. And the tactics look at design decisions that implement quality attributes and other requirements. We found that for tactics, there's no uniform documentation. So it's really difficult to say if this method would be applicable to CAS. And for patterns, it really deals with these high-level theories, this general theory, problem description, context, solution. So that might be a really good way to frame our decision-making process when we're looking at the executing of the preferences. We're looking at product families. So one of the big issues here that we see in the systems of systems or systems architecting field is how to best group these different systems in our architecture, right? What are the branches? What are the nodes that we're looking at within the architecture? Product families from the design engineering community might be one key area that we are going to be pulling approaches from. And finally, we're going to want to demonstrate our execution of the preferences. So right now we're developing a database of tanks from the World War II era in order to be able to examine how the different communication methods and how the different execution methods and so on really impacts the decisions that are made. So if we communicate certain preferences, how does that impact our tank choice or tank decision? And if we communicate a different preference, how does that impact our decision making there? Of course, we're developing models in order to enable analyses to understand those decision-making processes, cost estimation, success, reliability, maintainability, and so on. I'll focus on those tanks. We're identifying approaches, again, from different communities, understanding the context and assumptions, selecting and adapting an approach to CAS, and then implementing and demonstrating. So in conclusion, what are we doing here? We're doing the exploration task has defined the problem landscape that has covered us from March until now. And now our next steps is that we're going to go out into these different fields of engineering, psychology, business, marketing, and so on, software engineering, all of these different areas, and look at the different approaches that they've developed, understand their assumptions and context, and then apply it to this new context and understand, can it be implemented into CAS, right? Selecting the best approaches and doing modifications if necessary. Putting big warnings on different theories and limitations to validation as well. The 4 different areas we're going to be looking at, again, elicitation, representation, communication, and execution. And with that, I'd like to take any questions that you have. I'll be responding to them in the chat. And I want to thank you all for attending, and thank you to the sponsor for allowing us to do this awesome work and improving the systems architecting field. So thank you.